Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. And good evening for everyone. In the last class, actually, we have taken the introduction to IPv6 networks. And for today, we are going to continue with IPv6 routing technologies. In this presentation of today, that I'm going to explain about what they call it OSPF version 3, which is designed for to support the IPv6 networks. And before this, we have already taken the OSPF version 2, which is supporting the IPv version 4. So OSPF version 3 is somehow similar to the OSPF version 2 with some differences. And for today, I'm going to explain to you how the version 3 is different than the version 2. And what is the differences and how we can deal with them. The objective of this class actually is to allow you to describe the characteristics and operations of the OSPF version 3, and also to let you able to configure the OSPF version 3 routing protocols for IPv6 networks. Our class of today is not hard. It's very simple, but it's somehow tricky because we have to focus on some new concepts and some new ideas, which is a little bit different compared to the version 2. So in this slide, we have a network of 4 routers that supports the IPv6. And here we have the configuration. We have already configured the loopback 0 for this router. We have assigned a router ID similar to the OSPF version 2. For the router ID, the ID is supposed to be in the format of 32, similar to the IP version 4. But for the loopback, we can use the IP version 6. And also here for the another thing I want to mention, the router ID cannot support the format of IP version 6. So it must be in the format of IP version 4. This is only for the router ID. And router ID has the same features, have to provide the same features. It has to be a unique ID. Also, it has to be somehow representing the situation of how the router are connected. Another thing here, we have to configure also the interfaces, network interfaces that is connected to the network, to the other routers. So here, every interface must have an IP version 6, as you can see here. Then here, the OSPF version 3 is working actually based on exchanging information similar to the OSPF version 2. In order to send or exchange this kind of information, they have to use something called link local address. Link local address. So the OSPF updates are sent to all SPF routers address that is FF02:5. So if you remember in the previous class, if we go to the table here, what is this? This is the main table, and you can see here FF02:5. So here in the previous class, FF02 is not here, but because it's already here, FF02 is here. What is this? It's a multicast IP address. So the FF02 is a multicast range. And here we have the range FF02:1. This one is local, link local for all nodes to be to exchange the information for the information that's related to IPv6 addressing. And the FF02 is also a link local. FF02:2 is a link local to exchange addressing information among the routers. This one among nodes, this one among routers. Also, we have FF02:5, which is also a link local, as you can see here, link local. But this one is used to exchange the information among the OSPF routers. I hope this is clear. We have always to remember this kind of IP addressing and their reservations. Also, link local addressing used by default to define the next hop. So based on the link local configuration of the OSPF version 3, so we have to configure this link local manually. We have to assign a link local for every interface involved in the OSPF network. So based on the link local addressing, the routers will decide or will find which one is the next hop. So let us go through here this information to see what do we have here. OSPF is the version of OSPF that is used over IPv6 networks, and in terms of communication assumes that each router has been assigned link local unicast address. I think this is very clear. So manually we have to go through the to every router and we have to assign a link local unicast address in this range, the FF02:5. On each router's attached physical links. Okay. OSPF packets are sent using the associated link local unicast address of a given physical interface. So the packet of the OSPF will be sent to an interface, to a physical interface, but it will use link local unicast address of a given physical interface as the source address. So the physical interface, the one that's used to pass through the packet through the network is going to be used as a source address. Then a router learns the link local address of all other routers attached to its link and uses these addresses as a next hop. So this next hop information will be used during the packet forwarding. This operation is true for all physical links with the exception of virtual links. So in case we have virtual links, this will be will not be involved in this. So it's not true to have this behavior for the virtual links. So the virtual links which are outside the scope of this material. Reserved all SPF routers multicast address has been assigned the value FF02:5, reflecting the multicast address. This one, actually, this address is similar to the multicast address that we have learned in when we take the OSPF version 2. So OSPF version 2 uses the multicast address of 224.0.0.5. In here, in the OSPF version 3, we use the multicast address of FF02:5. So there's some things similar, some things are different. For which it should be noted that the two versions are not compatible. That's why, because of this, due to the difference of the multicast IP addresses of the two versions, from here we can understand that the two versions are not compatible. So they cannot work together, they cannot do a cooperative work between them. So all routers running OSPF version 3 should be prepared to receive packets sent to this address. So we have to manually go and configure the IP addresses of the multicast, and also the link local unicast. We have to configure all of them manually. Also, hello packets are always sent to this destination, as well as certain OSPF protocol packets during the flooding procedure. So everything actually is based on the multicast address and the link local unicast. Okay, in this slide, we can see that this slide actually is to show the OSPF version 3 router ID. So router ID, as I mentioned, is supposed to be in the format of IPv4, as you can see here, 11113333. Also this here and here. So after that, we have to configure the interface, physical interface here to have a link local unicast, and also we have to prepare the router to deal with the multicast IP address in order to make these routers working in the same domain or in the same area. So here, as you can see, router ID is similar to the OSPF version 2. Actually, it's used to elect or to find the designated router and the backup designated router. So it's the main purpose of it is to find the highest router priority based on the ID in order to elect the DR and the BDR. So here, not based on any IP address, because in OSPF version 2, if the router ID is not assigned manually, then the loopback 0 is going to be used. But for this case, the router ID must be assigned manually, must be configured manually. You never forget this in the OSPF version 3. Okay. Router ID continues to be used to support DR and BDR election. So let us check here the information that we have below here, below the slide. The router ID plays a predominant role in OSPF version 3, exactly similar to the OSPF version 2. But in this case, we have to make it manually, must make it manually. But for OSPF version 2, it can be automatically using the loopback 0. So, and is now always used to identify neighboring routers. So based on the ID here in the OSPF version 3, based on the ID, we can identify who is the neighboring routers. Previously, they had been identified by an IP version 4 address on broadcast NBMA, which is the non-broadcast multi-access, and point to multi-point links. Each router ID, as well as the area ID, is maintained as a 32-bit dotted decimal value and cannot be configured using an IP version 6 address. So we have to remember this always. The area ID and the router ID must be in the 32 format. The router ID also continues to actively act as a tiebreaker in the event that the priority associated with each OSPF version 3 enabled router is equal. Also, in such cases, the designated router is identified as the router processing the highest router ID. So the DR will be elected based on the highest router ID available in the same area. Then hello message, to do this, hello messages sent will contain a router ID set to 0 if there is no designated router. If they don't have a designated router yet, the hello message will include the 0000 as a router ID to be exchanged. The same principle applies for the backup designated router. So for the backup designated router, it would be selected based on the next highest router ID. Exactly similar to the OSPF version 2. Then if a priority of 0, if the priority of 0 is set to a router interface, that means that interface is not going to participate in the OSPF version 3 election. So we'll deem the router as ineligible to participate in DR and BDR election. So priority 0 will disable the interface from participating the election. Router priority is only configured for interfaces associated with broadcast and NBMA networks. So here for router priority, we can configure it only when we deal with broadcast and NBMA networks. The multicast address, all the routers has been assigned the value FF02:6. So if you remember in the previous slide, we used this range, FF02:5 for the link local address. Don't forget it. And also this range is used for the what they call it for the multicast address. But here to exchange the what they call it to exchange here to exchange the information. So the multicast used here, multicast address for all routers, has been assigned to the value of FF02:6, which is equivalent to 224004 in the OSPF version 2. So in the OSPF version 2, we use this multicast address to exchange information for the all D routers. But for this case, we use FF02:6. Also, as you can see here, the thing is covering the slide, so I have to move it at the top side. The designated router and backup designated router are both required to be prepared to receive packets packets destined to this address. So this one. So we have to go to the BDR and the DR and BDR and configure them manually to receive the packets destined to this to this IP address. Otherwise, the OSPF version 3 is not going to be functioning very well. Okay, here we have something called bare link behavior. Actually, OSPF version 3 introduces a new concept, which is totally different than the concept in the OSPF version 2. So this concept is to work based on a link, not based on the what they call it on the subnet mask. In the OSPF version 2, everything is based on the subnet mask, but in here, everything is based on the link. So IP version 6 refers to the concept of links to mean a medium between nodes over which communication at the link layer is facilitated. Interfaces, therefore, cannot connect to links, and multiple IP version 6 subnets can be associated with a single link. So one link can be used for multiple subnet masks. But for the IP version 4, if the subnet mask is different, so the nodes cannot communicate. But in our case, even if the nodes are under different subnet masks, but they are associated to the same link, then they can communicate. This is somehow confusing, but this is a new idea under the OSPF version 3. So we have to keep ourselves awake all the time to avoid making mistakes, and also to understand how it works. So again, interfaces, therefore, connect to links, and multiple IPv6 subnets can be associated with a single link to allow two nodes to communicate directly over a single link, even when they don't share a common IPv6 subnet mask. I hope this is clear. It's very, very important. So I think we have to highlight this always, all the time, to keep it in mind. So OSPF version 3, as a result, operates on per link basis instead of per IP subnet. So this is the new concept. It operates based on per link basis instead of per link subnet, per IP subnet, as is found within IPv4. The term link, therefore, is used to replace the terms network. So here, link is going to be used to replace the term network and subnet, which are understood within the OSPF version 2. OSPF interfaces are now understood to connect to a link instead of an IP subnet. Also, this change affects the receiving of OSPF protocol packets, the contents of hello packets, and the contents of network LSAs. Last time, when a router sends an LSA, all routers inside the subnet mask will receive. But in this case here, in the OSPF version 3, if the router sends an LSA to a link, only routers connected to that link or associated to that link will receive that LSA, even if they are not from the same subnet mask. The impact of links can be understood from OSPF version 3 capability to now support multiple OSPF protocol instances on a single link. So because of the link concept here, now we, in the OSPF version 3, we are able to have multiple OSPF protocol instances on the single link, So we can enable multiple OSPF instances on the same link. Where separate OSPF routing domains that wish to remain separate but operate over one or more physical network segment links that are common to the different domains. IP version 4 requires isolation of the domains through authentication. Last time we learned how to do authentication for the OSPF version 2 to avoid the unauthorized people from interrupting the routers. So IP version 4 requires isolation of the domains through authentication, which did not provide a practical solution to this design requirements. The per link operation in the OSPF version 3 also means the hello packet no longer contains any address information, and instead it now includes an interface ID that the originating router assigns to uniquely identify its interface to the link. Okay, so in this version of the OSPF, the hello message no longer contains any IP address or any address information. Instead, it includes only the interface ID of the originating interface. For this reason, the security is the authentication or the security feature of the OSPF is already removed in the version 3. Why? Because the OSPF is based on the OSPF version 3 is based on the IPv6, And now the security is already enabled in the IPv6, which can be used by the lower layers or the other protocols. Authentication in OSPF version 3 is no longer supported, and as such, the authentication type and the authentication value fields from the OSPF packets header no longer exist. So this AH and ESB of the IP version 6 is going to be used. But from the header of the OSPF, the authentication fields are already removed. So as of IP version 6, changes to the IP header have allowed for the utilization of security protocols that were only present in IP version 4 as a part of the IP6. During the era of IP version 4, the IP version 4 actually was based on something called IP security. So that's why OSPF version 2 can be based on the IP security protocol, or also can enable the authentication of itself. But for the OSPF version 3, because the IP version 6 now by default has enabled the authentication and the security features, so the OSPF version 3 no longer needs the authentication feature. That's why. Since initial TCP/IP development in the late 1960s was never designed with security in mind, since security of TCP/IP at the time was not foreseen as a future requirement. This is why they did not have security in the IP version 4. With the security improvement made to IP version 6 and the utilization of IP extension header, which is this extension header of the IP version 6, in the protocol suite, OSPF version 3 is capable of relying on the IP authentication header and the IP encapsulating security payload to ensure integrity as well as authentication and confidentiality during the exchange of OSPF version 3 routing information. So from here we can summarize that the OSPF version 3 cannot have any configuration related to the authentication. Why? Because it relies on the security of the IP version 6. Okay, that's all about the authentication. So here, OSPF authentication removed in OSPF version 3, instead relying on the AH and ESB extensions header of the IP for security. These two headers, this header, this AH and ESB actually is an extension of the IP version 6. If you forget, you can go back to the previous slide and you can go to the header to remind yourself by the contents of the header or the header format. So this is the header format, and here is the extension. Here is one of the extensions. So extension can be used for fragmentation and also can be used for the IP security. Okay. Hopefully it's clear. And now we are going to learn how to enable the OSPF. In order to enable the OSPF, we have to use to enable the IP version 6, because OSPF version 3 is not going to function with the IP version 4. So the first thing, we have to enable the IP version 6 first using this command. Then after that, we have to use the command OSPF version 3 to enter the interface of the protocol. Then after that, we have to assign the router ID here, as you can see in this example, 1.1.1.1. Then after that, we have to go to this interface, physical interface. Then we have to enable the IP version 6 also. Then after that, we have to assign the link local of the physical interface here. So IP version 6 address and we give the address of the link local. So this address is FE80 :0. Let us go back here. FE80 something. Am I right? :1. So here, this one is a link local used for unicast. You see, we're still following the reservations, the table of reservations from the previous slide. So always you have to remember that that table, you have to keep that table in your mind to always understand why they use this range or why they use the other ranges. Then after this, we have to use this command, OSPF version 3, inside the interface view, and we have to give a number. This number actually is like a profile for the OSPF for any protocol. If you leave it empty, it will be by default number 1. So similar to the OSPF version 2, actually. So here we prefer to use number 1, OSPF version 3, 1. Then after that area, we can assign area 0, which is in this format, also in the format of the 32 bits. After that, we have to, after we do this, we have to go to the loopback 0 here. As we can see here in the loopback 0, we need to assign this IP version 6 address. So we have to enable the IP version 6 first using this command. And after that, we have to assign the needed IP. After this, we also have to link this interface to the same OSPF area in order to make it, to allow it to be in participating in the OSPF version 3 election. Also, we go to the router B. We do the same thing using different values, which is already available here. Let us go and check what do we have here. Implementing OSPF between peer requires that the router firstly be capable of supporting IP version 6. So we have to enable the IP version 6 before we use the OSPF version 3, exactly similar to other protocols, other routing protocols like RIB next generation. You remember the RIB, last time we have taken RIB that supports the IP version 4, but now this one, RIB next generation, is the one that supports IP version 6. So OSPF version 3 and RIB-NG both need the interfaces to, or the routers to support the IP version 6, otherwise they cannot function. Additionally, the router must also enable the OSPF version 3 protocol globally in the system view. So here, OSPF 3 have to be enabled also. So we enable the IP version 6 first in the global view. Then after that, in the system view globally. And after that, we have to enable the OSPF version 3 for the router. Then after we enable it, we can go and configure it. Each interfaces should be assigned an IP version 6. Otherwise, they cannot function and they cannot support the OSPF version 3. During the configuration of RIB-NG, this is out of the scope of this course, it was demonstrated how the interface can be automatically configured to assign a link local address. This is not our business here, but only we mention it here. In this example, an alternative and recommended method of link local address assignment is demonstrated. So here we can see we have link local here and another link local here. Okay. The link local IP version 6 address is manually assigned and designated as a link local address using the IP version 6 command. As you can see here, this is the IP version 6 command to assign the link local. if the address associated with the physical interface is a global IP version 6 unicast address, the interface will also automatically generate a linked local address. So if we assign an IP address to with the physical interface, which is a global IP version 6, then that the IP address, the same IP address will be used for that, or will also automatically generate a linked local address. Also here, in order to generate an OSPF version 3 router, the example demonstrates assigning global unicast address to the logical loopback interface. So this one global unicast address is assigned to the loopback 0 interface. Okay, this one is a global unicast address. Why? It started with 2001. But the first one is a link local. Okay, the physical and logical interfaces both should be assigned with the OSPF version 3 process and be assigned a process ID, typically the same ID unless they are to operate as separate instances of OSPF version 3, and also be assigned to an area, which is the case is confined to area 0. So here we can see this one enables the OSPF, and also this one loopback is also enabling the OSPF. And here, this one is virtual interfaces or logical interfaces, and these two are physical interfaces. And here we can enable the OSPF using this interface, physical interfaces, and also we can use this OSPF through the physical interfaces as another link. So we can have multiple instances of the OSPF version 3 using the same link. I hope this is clear. Configuration validation. To validate or to display the OSPF version 3 configuration, you can use this command, display OSPF version 3. Then you can see here, it will show you the information, the ID of the router here, and also it will tell you about other things like multi-VPN instance is not enabled. Then here we can see SPF intelligent timer, milliseconds, and the maximum is 10,000. It starts with 500 and hold 2,000. Also LSA intelligent timer, we can see here 5,000, 500, hold is 1,000. LSA arrival interval is 1,000 millisecond. Default is E parameter is metric 1, tag 1, type 2. You can see all of this information. And also number of full neighbors is only 1, because we have only 1 neighbor in the previous example. Number of exchange and loading neighbors is 0. So following the configuration of neighboring routers participating in OSPF version 3, the display OSPF version 3 command is used to verify the operation and parameters associated with OSPF version 3. Each router will show a running OSPF version 3 process and a unique router ID. If the adjacency between neighbors is established, the number of full state neighbors will show a value greater than 0, like you can like what you can see here. So that's all the summary here. There is one question: what is used to uniquely identify each neighboring node running OSPF version 3? What's used to uniquely identify is for sure is the router ID, which is a 32-bit router ID, similar to the one used in the OSPF version 2. So that's all for today. And this class is also going to be uploaded on the Butterblast, and inshallah for tomorrow. For tomorrow we have We have another class, another topic. We have to take the routing protocol, which is the BGP. See you, inshallah, for next class. And I hope everybody is keeping safe and maintaining good health with the family at home, inshallah, and try to enjoy your time. Try to give enough time for the course. Try to practice on using the simulator because we cannot meet we cannot meet at the lab as before. That's why you have to do a lot of tasks. And if in case you have any problem or any issue, anything is not functioning well, or you cannot configure easily, you just contact me on WhatsApp. Then I will do my best to help you, to assist you as soon as I can, inshallah. So see you soon, and assalamu alaikum wa rahmatullah.